Hey, happy morning to you, pre-algebra. I'm sure it is good to be back to your video. Just we'll see what we'll be doing with videos. Like I said, sometimes it'll be live instruction, sometimes it'll be video. But we've got a lot to cover today. Make sure you watch this video carefully. Again, this is me, actual Mr. T, telling you. I mean, just you can't. Doesn't mean that you can ignore me just because I'm on a video. But you gotta pay attention so that you can understand. So first, we got to get through our joke today, and this one's great. I love it. So what do you call a guy who never farts in public? A guy who never farts in public is called a private tutor. Yeah. All right. We are page 565 in your book. Make sure you turn there, follow through these example problems as I do them on the board or the computer for you and with you. So first thing, hopefully this chart should look somewhat familiar. Identifying real numbers. We're going to be talking about how do we, we're going to approach algebraic equations where we see a lot more difficult number problems. So first thing is we're going to be identifying, then we're going to be comparing, and then we're going to be matching, and then we'll finally be solving some problems that involve rational and irrational numbers are real numbers. So the first thing to break it down, the smallest group is whole numbers. That's right here in the middle. So these are numbers like 0, 5, 107. Those are whole numbers. The next category that whole numbers are a part of would be integers. Integers simply include negative numbers. So we have -7, -18, and then we have the square root of 25 with the negative sign on the outside. That would also be an integer because the answer, when we break it down, square root of 25 is 5, negatives on the outside, so it's -5. So that is also an integer. Next category would be rational numbers. These include decimals and fractions. So 1/4, 0.35, and also it includes decimals that repeat. So they have to be repeating. So 0.7 repeated, or it could be 0.23 repeating. However it repeats, but the thing is that it repeats. Those are rational numbers. Irrational numbers are numbers with decimals that do not end. They don't repeat and they don't end. So pi, the square root of 5, whatever this number would be after the ... the number continues. They are irrational. And finally, all these numbers are real. Now, it is way above my knowledge of understanding of numbers that are not real, but they do exist. Crazy stuff. When you go to college, you can study it. But not today. So first thing is just kind of identifying what our numbers are. So start over here on the left side. I just kind of broke it down to save some space. But identify what is 0.7. What category does that fall under? Is it a whole number, an integer, rational, or irrational? That's what it's asking. So I know 0.7 isn't a whole number. I know it's not an integer, so it stops, the decimal stops, so then it must be rational. So I'm going to put rat, period. All right, the square root of 100. Well, square root of 100 means what number can be multiplied by itself to get to 100, and that would be 10, and 10 would be a whole number. So WH. -6, we have a negative sign, and then it is a whole number, so that makes this one an integer. And then lastly, pi, we learned, is irrational. Okay, so some of the problems, the first few problems that you're going to come up against are simply just identifying what category do the numbers fall in. All right, so you can look back at the chart for that. Next set, in the middle of the page on 566, we're going to be comparing numbers. So our first comparison is we're going to see is it less than, greater than, or equal to? What is when we compare 3 1/3 and the square root of 15? So if I do 1 divided by 3 times 3, that's not right. plus 3. So I have 3.3333 repeating. Alright, so that's what this is equal to, 3.3 repeating. That's not a 5, that's a 3 with the repeating sign. And when I find the square root of 15, come on. Oh, I'm pushing the wrong button. I get 3.8. 3.8. So I know that now the square root of 15 is greater than. So do the same thing. 7 2/5 is 7.4. And the square root of 57 is 7.5. So I know that this is greater than. Okay, simple breaking it down using your calculator. Again, for these challenging square roots, you need to use your calculator, so make sure you have it handy. Alright, that's comparing positive or greater than, less than, or equal to. Those are your 3 choices. Alright, the next thing at the bottom of the page on 366 is ordering numbers, a set of numbers, from least to greatest or greatest to least. So again, you're going to need your calculator to figure this one out. So I've got the square root of 30 is 5.4. So right now that's my front runner. Then I have 5.6. 15 divided by 3 is 5. So that's actually my smallest. 15 divided by 3. Then I know that 5 2/3 is going to be 5.666666, repeating forever. So square root of 30 was what again? 5.4. So that's going to be my next one. And then 5.666 repeating is a bigger number than 5.6. So I'm going to put 5.6, and then finally 5 2/3. Alright? So pretty simple, just identifying a little bit more work of looking at the square roots and that nature. Alright, now the last thing. I know this is kind of fast, but again, I want to keep these videos short for you. So now what do we do to solve an algebraic equation when we're dealing with a square? Well, just like any normal algebraic equation, we want to do the opposite sign to isolate our variable. So the opposite sign meaning the opposite mathematical equation. That doesn't sound right. It's just not coming to me today. But you know, if it's addition, you subtract. If it's multiplication, you divide. If we're squaring, then we do the square root. So to find the answer to A, we are actually going to square root both sides. So now this cancels out because square root is the opposite. So we're left with A, and the square root of 36 would be 6. So our answer would be 6. However, could that be our only answer? Could it possibly be something else? What about negative 6? 6 or negative 6 could be our correct answer because both can fit correctly. If you square negative 6 times negative 6 does equal positive 36. So be careful. Make sure that you add in 6 or negative 6, your positive number or negative number, if that applies. Sometimes it won't, and we will see that. Okay? Now let's look at example B. We have 2n squared equals 170. Now, probably you're thinking like, oh, we're just going to square root it right away. Square root of 170, ooh, that's not so good. We don't know. That's kind of an ugly number. Actually, we want to get our variable squared all alone. Just like how if you had 2n, you would want to get the n all by itself. We actually want to get n squared by itself first. So we're going to divide both sides by 2, and then we're left with n squared equals 170 divided by 2 is 85. Alright, and so now we do our square root. And it is going to get ugly. Cancels out. So we have n equals the square root of 85. And remember, we're dealing with our plus or minus because either number would work. So 85 square root, and we want to round it to the nearest, does it say? Nearest tenth? Yep, round to the nearest tenth if necessary. So I have 9.219, so 9.2. And this could be plus or minus. So you could write it like that, or you could do 9.2 slash negative 9.2. But I think this is much nicer. So put plus or minus the number. Okay? Pretty simple stuff. Nothing too new or challenging, I hope. But as always, if you need help, ask. And I am more than willing to help you out. Alright. Work hard. I'll see you in real life.